We're going to calculate the equilibrium composition using ice tables. For these type of calculations, you want to make sure that your equilibrium is balanced. From there, we can write down our equilibrium constant expression, which is K equals the concentration of products raised to the power of their coefficients over the concentration of reactants raised to the power of their coefficients. A lot of the times when we're solving for our unknown, this would require us to rearrange our expression into the quadratic equation in standard form. Once we have this in standard form, we can use the quadratic formula to solve for x. Let's take a look at an example. Calculate the equilibrium concentrations of all substances when a 500 milliliter flask is filled with 1.3 moles of hydrogen and 0.7 moles of chlorine for the reaction below. So, when it says to calculate the equilibrium concentrations, this is a big hint that we need to use something called an ice table. So let's get started. I want to make sure that my equation is balanced, and it is. And now I want to pull out my given information. They've given me the initial moles of my starting material, of my reactants, and they've given me the volume of the flask. So for given information, I'm going to go ahead and start calculating my initial concentrations. Remember that concentration is molarity, which is moles over liters. And I also have information for chlorine. So this is my initial concentration information. Now I'm going to set up my ice table. I need to always have my balanced chemical equation on the top of my ice table. And on the side, I'm going to have an ice. I for initial, and I'm going to put my units. C for change, and E for equilibrium. So initially, I have 2.6 molar of H2 and 1.4 molar of Cl2. And initially, I'm going to go ahead and assume I have no product. Now, the change is going to be plus or minus the coefficient times x. And by convention, we're going to call the reactants the minus side and the products the plus side. So I have a coefficient of 1 in front of the hydrogen, so it's going to be minus x. A coefficient of 1 in front of chlorine, so this is going to be minus x. And I have a coefficient of 2 in front of my HCl, but HCl is a product, so this is going to be plus 2x. Equilibrium is just adding initial plus change to give me my equilibrium. Initial plus change equals equilibrium. Initial plus change equals equilibrium. So they want us to find the equilibrium concentrations from our initial concentrations. This requires the ice table, and I need to solve for every equilibrium concentration on this table. The next thing I want to do is remind myself of this equilibrium constant expression. Remember that the equilibrium constant expression is K equals the concentration of the products raised to the power of its coefficient over the concentration of the reactants raised to the power of its coefficients. All right, so we're going to start substituting some numbers so that we can solve for our x. So I'm going to go ahead and rewrite that. And I'm going to start plugging in the numbers I do know. they've given us K, and our equilibrium number, or our equilibrium concentration for HCl is 2x, but I'm going to have to square that. And for H2, it was 2.6 minus x. And for Cl2, that was 1.4 minus x. Now I'm going to go ahead and clean it up. 4.42 equals 4x squared. I'm going to have to do FOIL for the denominator. I'm going to get that denominator on the other side by multiplying. I'm going to get that 4x on the other side so I can get this in standard form. Okay, so I have this in standard form, so I can tell you that my A is going to equal to 0.42. My B is going to equal to negative 17.68, and my C is going to equal to 16.088. I can go ahead and plug this into my quadratic formula. And x is going to equal to 41.1647, or x is going to equal to 0.930572. So we've got two x values. We have to choose the one that makes sense, meaning we have to choose the one that doesn't give us a negative answer. So if we go back to our ICE table, there's going to be one of those x's at equilibrium that would cause a negative answer. That's going to be this one. So x is equal to that number. Okay, we're not done. Now we have to go back and plug in our values for equilibrium. All right, we're going to start with the first one. These are equilibrium concentrations. So for H2 at equilibrium, we had 2.6 minus x. I'm going to go ahead and substitute what x is, and that will give me 1.7 molar. I'm going to do the same thing for Cl2. At equilibrium is 1.4 minus x, and that's going to give me 0.5 molar. And then we have HCl, and at equilibrium, that's 2x, and that's going to give me 1.9 molar. Good luck and keep practicing.